Hi guys, the Casual Analyst here. On today's video, we will explore the data from an e-commerce platform. This is a real life data and there's a lot of things that we can do with it. The analysis of this data is divided into many parts, with this video being the first episode of this series. The main goal of today's tutorial is to perform the RFM analysis, which is a famous marketing analysis framework. Hope you enjoy it. First, we will import the essential libraries, which are pandas and numpy. We will use these two libraries throughout our project. And then we load all the data. To download the data, you can click on the link in the description and it will lead you to the page of Brazilian e-commerce public dataset by artist. It contains a lot of data connecting with each other. And in the data card section, you can also see the data schema right here. We have a lot of data set ranging from the customer to product to even seller. This gives you a lot of interesting questions to analyze. We will start by performing RFM analysis. And in case you don't know about RFM analysis, it's a marketing analysis framework. It looks at three metrics: the recency, the frequency, and the monetary. The recency answers the question, what was the last time the user interacted with our firm? The frequency answers the question, how frequent that user purchased from our business. The monetary metric answers how much value a customer has contributed to our firm. You can always research more about this RFM analysis framework. Just click on Google and search for RFM analysis. There are many blogs with deep discussion on this technique. And one last thing about this RFM analysis framework is that it's used to segment your customer base. Right? For each combination of the recency, the frequency, and the monetary matrix, a customer will be assigned a name, and this name is the segment that they belong to. There are a lot of segments right here. These information are very important. For example, if we know that a customer belongs to the champion segmentation, which means that this customer frequently buy from our business and they have contributed a lot of value to us, then we can focus our resource on promoting product to these customers. So in RFM analysis, you have to calculate three matrices, right? The recency, the frequency, and the monetary. So let's now define exactly what is the recency, what is frequency, what is monetary, and how we can get those information from the dataset. So let's start with recency. Now, once again, the recency answers the question that what was the last time the user interacted with our business. It wants to calculate the time between the current day and the last time the user purchased or visited our platform. Now, to get this information, we need two pieces of information. That is the current day, and second is the latest purchase or visit day of the users. Okay, so now let's further break this down. The current day of this data is not the current day of the video, okay? It is not the current day of this video. It's the current day of the data set. This data is published in 2018. And so to get the current day of the data set, we simply just get the max value of the column or the purchase timestamp. This column shows the timestamp of each order throughout the years that are recorded in this data. This column can be found in the order data. And next, to get the last time a customer purchased from our website, we can also simply just get the max value of this column. But this time, we have to group by the customer unique ID. So now let's start coding. Okay, let's begin with getting the latest day of purchase for each user. All right, getting the latest day of purchase for each user. To do this, we have to merge the data. We have to merge the customer data with the order data. So let's merge it. the customer data, we will merge it with the order data on the customer ID. You can see it more closely like this. These two data sets, it has the same key, which is the customer ID, so we can merge them based on this key. Let's call this the recency table, because we are calculating the recency matrix. Okay, now let's print this out. It has roughly 100,000 rows. To get the max value of order purchase timestamp, we have to first group by the customer unique ID, and we perform the aggregation function. On the column order purchase timestamp, we get the max of it. So this code right here, it means that for each customer, I want to get the max value of the order purchase timestamp, which means the latest timestamp. Okay, but let's just reset the index, make it look cleaner again. Okay, and here is the latest day of purchase, but the data type of this column is not data. Here I will print out the information of the data frame. You can use that with the function info, and you can see that the data type is the object, it's not a data. So we have to convert it into the data type. We do that by using the function from Panda. It's the function toData, and we want to transform this column and update it. Okay, convert to data D type. And then I would like to calculate the current day of the dataset. The current day of the dataset can be get from the max value of the column order purchase timestamp, but in the order data frame. And again, you have to transform it into a datetime data type. Okay, and we name it the current day. Now let's just print it out a little bit. Print this, or display this, and the current day. Let's see it, because these are the two information that we need to get the recency. Okay, this is the current date, and this is the recency table. Now we can just simply calculate the days between these 2 days by getting the recency table. With the column order purchase timestamp, we subtract for. Oh no, it's the opposite. We have to get the current day and subtract for this column. And let's see this. Let's see the result. Okay, we receive both the number of days and the hour, but we are only interested in the number of days, so we have to get rid of all of the unnecessary information. We can do that by applying a lambda function. So first of all, this is a series. So in a series, if we want to perform a function on each row, we can use the apply function. And the second thing is that lambda is basically the same with function. It's just that lambda, when we write down, is shorter than the define function. Okay, so this lambda function, what we want to do with the x is that, first of all, we convert to string, because look at the type, it's a time delta. So we have to convert to string to perform the split function. When you convert to string and you split it, it will split based on the blank between these characters. So we will have a list of 3 values. The first value is the number of days, the second value is the string days, and the third value is the string of this hour right here. And we only interested in the number of days, so we just get the first value. And when we do this, the output will be a string. So we have to convert into an integer value. And now we have it. I will run this function and hopefully it will work. Okay, the data type is integer and we have the days between. Now let's name this one. Let's name this one days between. Right? Okay. Okay. So what do we have to do next? What do we have to do next? Let's just print this table out. What do we have to do next? So in RFM analysis, we have to score the recency of each user. We have to score the frequency, the monetary, and the recency of each customer based on the Likert scale from 1 to 5. Okay, a Likert scale from 1 to 5. So for example, the first 3 customer, this one will be, for example, 1, 1, 2, and 5. Meaning that we have to convert the data of this column to another number ranging from 1 to 5. It's a Likert scale. And because we have to do it 3 times for each matrix, it's more efficient if we define a helper function, define a function that's scoring the data for us. That score the data from 1 to 5. So first of all, how do we score the data? Or we can score the data based on the quantile. Right? Based on the quantile, the first thing is that we have to calculate the quantile of the data. And second is that we will label the data based on the quantile value. Because the quantiles of a dataset will split the datasets on the percentage of observation. And if we calculate 4 quantiles and use those quantiles to score this data, it will represent the rank of the data very efficiently. And this method is widely used. For this technique, you can search online and research more about it. So first of all, let's just calculate the quantile of it. For quant, in this list, there's 4 quantile. We got the 20% quantile for T, CT, and AT. We will calculate the quantile value of X in that particular quantile. And let's create a list so we can update it for every value. For every value, we will update delete. We will update the list. Okay. And this will give us the quantile value. And next, we will label the data based on these quantile value. To do that, we will have to apply a function. Let's name it labeling. On each row. So it's better to just define a function rather than using the lambda function in this situation. So the labeling function will look at the data and ask, well, if the data is less than the first quantile value, which is the 20% quantile, if it's less than that, then it will receive a score of 1. And if it is less than the second quant type, we return the score of 2 and continue to do so. I continue to do so. Okay. 2, 3, 3, and 4. And the last one is 5, which is the highest score. And we will apply this function on every row, and we will return the DF result. Okay, now let's test it. Okay, we will apply the scoring function on the column days between, and it will get us a series or a column with the value ranging from 1 to 5. Let's name that column the recency score. And after that, we will print out the result. Okay, it worked. Very nice. Recency score here. We can also see the distribution of it using the value count function. It should be the same. It should have a uniform distribution. See, the count for each score is roughly equal. Because we are using the quanti. It split the data out with the same length for each interval. Okay. So next we will calculate the frequency matrix. The frequency matrix is calculated by getting the number of times a user purchased from our website and divide by the time they have been our customer. So let's just give an example. So let's say we have the data of this customer who have purchased from our platform for 10 times, right? And we also know that they have been our customer for 100 days. So if we have those two information, we can get the 10 time of purchase divide by the 100 days of being our user, and it will give us the average number of time that user purchase product on our platform on a given day, right? Another way to express it is that if we get the 100 days of that user being our customer divided by the 10 times of purchase, then the result is 10, and 10 means that on average after 10 days that user will buy a product or will order one time on our platform. And those two ways to expressing the result, both of them represent the frequency of purchasing of these users. So now let's break it down a little bit. The first part of the equation is the number of time a user purchased from our website. We can get this information basically from counting the number of time a user ID appear in the order data frame, right? Because the order data frame, it store every order, and if we count the number of time a user ID appear on this data frame, we can get the number of time that user purchased from our business. The second part of the equation is the duration, or you can say it's the how long the customer have been our customer. We can get that information by, just subtracting the last day that user purchased on our website. The second part of the equation is the duration that the user being our customer, right? So we can get this by subtracting the last day of purchase with the first day of purchase of that customer, right? Just get the last day and subtract for the first day of purchase. And now let's begin to code. Okay, so now we will merge the data just like we did with the recency matrix, and we'll get three information, which is the mean value of the order purchase timestamp, the max value of order purchase timestamp, and the number of time that customer ID appear in the order data frame. Okay, so let's just merge the order data frame with the order data frame based on the customer ID, and let's call this one the frequency table. And we will group by the customer unique ID, right? For every customer, we want to get this information. The first is the mean of the order per timestamp. Second is the max, and the third one is the count, which will represent the number of time that customer purchased from our business. And we can count like any column. We can count any column. Let's just say this is it, order ID. We can count order ID and update the table. Let's make it look better by resetting the index. Okay, now let's see it a little bit. Let me annotating a little bit, merging df and getting interested information. As you can see, this data frame, the column, it looks a little bit weird. It's because the column right now, it has two levels. If we print out the column, it will look something like this, and we don't like this, right? It looks really ugly. So we can directly change the column. We can specify the exact column that we want it to represent, to show us. Okay, now update it. And now if we show it again, it looks much more better, right? The next thing that we want to do is to get time, get a day between first and the last day of purchase. This will represent the how long the customer has been purchasing from our platform. Just simply get the max, subtract by the mean, and this one is, we will name it the days between. Okay, let's see it. And oh, I forgot. We have to first change the data type. We have to change the data type because these two columns, they are string, just like the previous task. We will call the function to datetime of max, and datetime of min, and then we will update the column. Okay, we update the column. Now I believe we will have the result. Okay, and just like in the recency task, we will have to apply a function that iterates through every row and get us the value that we wanted to get. First of all, we change it to string data type, and then we split it because the first value, because it's this one right here, is the 0, and we have to turn to an integer data. Okay. Let's run it one more time. Oh, I would like to show you the value count of that column because it's quite interesting. So now, as you can see, the length of this frequency table is roughly 96,000 rows, and when we print out the distribution of this table, of this column, the day between, roughly 94,000 rows are zero. It means that there are many one-time purchase customer in the data, and this is very bad. Now we can show the value of the frequency table where the day between have to be more than zero to see how many data do we have, right? It's just 2,000 rows, and that is quite small, but we have to do so because when the day between is only zero, then it's just a one-time purchase customer. There's no frequency, and even the monetary is not important because they do not stick to us. So it's better to just exclude the customer that only purchase from our platform one time and analyze the rest of them. Okay, get rid of customer, let's call it one-time purchase customer. We do that by updating the data frame where the day between have to be more than zero. Okay, and now we will calculate the purchase rate. The purchase rate, or you can choose on your own. You can either use the days between and divide by the count, or use the count divided by the days between. But just remember that those two ways must be interpreted in different ways. For me personally, I will use the count divided by the days to get the average number of purchase of a customer on a given day, on one day. Okay, because the predefined function scoring is suited with that way of calculating. So I will do it. I call this purchase rate. It will be the count divided by the day between. The day between. Okay, and I'm pretty sure that this will work. So the last step, we will score the purchase rate to get the frequency score, of course. This will be the frequency score. It will be, let's call the function again. We will rank the data based on the purchase rate column. And now I think is, okay, this one might work. Boom. Hope it worked. Okay, very fast. Frequency score. Now we can see the distribution of it. Very nice and clean. Okay, that is the frequency table. We move on to the monetary one. And the last metric is the monetary. This one is quite straightforward. We just take the sum of the payment value column for each customer unique ID, and we can find the column payment value in the payment dataset. Now let's merge them together. Payment. You just say payment dot merge with the customer. Oh, I'm sorry, because the payment data frame is linked to the order data frame. So we have to do two steps. First, we have to link the payment with the order, and then link the order with the customer on the order ID. And then we merge them with the customer data frame on the customer ID. And we will call this one monetary table. And now we will group. We group by the customer unique ID. And again, we will get the aggregation, but this time it will be the payment value. We take the sum of it, update the data frame. Again, reset index to make it look more clean, look cleaner. And now we can print them, the payment value. So let's just use the predefined function that we have defined. Score them. Let's call this column the monetary score. So as you can see, this step is very straightforward. Very straightforward. Okay. Now, for the last step, we will combine them. We will combine them all together. The monetary table, the frequency, and the recency. Merge them. Merge with the monetary on the customer unique ID, because every table has a column customer unique ID, and that is the key. We will merge on that key and continue to merge it with the frequency table again on the customer unique ID. Let's see, this is the final table. Let's see. Got 2,000 rows because the how function, the how parameter, is defaultly, it is set to be inner as default. So it only get the customer that appear in all three table. So it will exclude out all the rows that has the frequency or the days between less than 0. Right? Okay, we are almost done. Now, because we have 3 columns, 3 matrix, and this is a 3D dimensional data frame. But in order to interpret the result, we have to transform it into a 2-dimensional data frame. And we have to combine the frequency score and the monetary score. Okay, now let's just create a new one. Let's call it frequency monetary. That will be the sum of the frequency score and the monetary score. And we will apply the scoring function on this one too. Let's call this score. Boom. Now, let's see the final result. Okay, now we want to label these customer based on the combination of their recency score and the frequency score. We have to use a segment dictionary. And apply a function on each row. So on each row, it will look at the combination. For example, at the row with index 0, it will be the tuple 1, 5, and it will look up the 1, 5 in the segment dict, which is this one, 1, 5, and it will outputting the name of their segment. I get the name of the segment from this figure, and many other figure also do the same. You can check it out. Okay, so it's very easy. Let's just run this segment dictionary, and now what we would like to do is that we would apply a function to iterate through every row, and on each row what we would like to do is that, let's say lambda, what we would like to do is that we will get a tuple with the first value is the recency score, and the second value is the frequency monetary score, a tuple. And this tuple right here, we will look it up in the segment dig. Okay, we will look it up, and with what this one will do is that it will outputting the name assigned to that tuple. And in order to do this, we have to define the axis equal to 1. And now it will get us, when I run this, it probably will get us a series with the name of the segmentation of the segment that each customer belongs to. And let's call this one segment. All right, run it and show the final. Okay, we can see the distribution of segment once again, value count. Okay, so the last step that we will want to do is we will import the matplotlib SPOT to visualize the distribution of the segments. Okay, let's say fig in x equal to the subplot, and we will visualize a horizontal bar with the y and the width. The y is equal to, let's say this, final data. The y will be equal to the value of this one, not the index of that one, and the width is the value. Now let's see it. Okay. Hibernating is the most of them, at risk and loyal. Okay. Then what we can see here is that this business, when we have excluded every customer that is one-time purchase customer, the residual of them are still very unpromising, because most of them are hibernating, and hibernating is the worst of them. It means that the user have exit the business, and the second largest of them is the at risk, and this is also a negative segment. We also have the loyal, and this is great. The loyal is actually really great. But the two largest segment of them are a negative segment, so this business is facing some problems. And that's it. We have analyzed, we have go through a lot of code, a lot of problem with this RFM analysis. Congratulations. I hope you enjoy it.